Supposed to be flash. Is it? Sorry about that. That's better. So onward. All right. So why is we replacing the current pollution center, or PC as we refer to most often? It's in poor condition or primary concern. It was built in 1967, upgraded in 1979, so it's very old technology. Consistently exists some structural, operational, and maintenance concerns. Very hands-on annual operation plant. It's very old technology in today's world. BC Environment has deemed the facility as one of the highest wastewater treatment plants in the city due to the things that we've seen above: age, lack of redundancy, risk of potential impacts to users downstream. The discharge to transitory waters downstream from our plant. Scott mentioned the Tanaha Nation, so those folks will be impacted also. It's in a vulnerable location. Plant location is currently in the 200-year flood zone, prone to flooding possibility and potential damage, those kinds of events. It's a fairly vulnerable treatment process right now. It being as manual as it is, it takes a lot of greater effort and a lot of finesse just to keep the plant running the way it's expected to and required to. As a lot of people know, we do have or have had in the past odor, some noise concerns from the existing waste treatment plant. Its original design didn't consider odor and noise as we do today in current designs. So that is something that we worked hard to mitigate over time. This year was probably one of the better years for the odor situations. But, we do still hear the plant operating. So the things about the new water treatment plant, what are the benefits of that? Obviously, the age and condition will be a new facility. Modern construction, eliminating the age and poor condition issues. Will feature several public-facing greenhouse and work buildings designed to be very close to residential area. So we had to consider how that would impact people that would be in that area. The new location, it would remove this particular plant location would remove from the floodplain from Mark and St. Mary's River, eliminating possible or reducing possible downstream contamination issues from any flood event. Safe, effective treatment process. So the Organica Food Chain Reactor, FCR, it's called, is a new fairly innovative technology treatment process. It's something that's used a lot elsewhere, not as much in North America, but certainly in Europe. Will support Kimberley's climate resiliency by utilizing water within the facility. So that's within the design currently, and a potential to use that reclaimed water elsewhere in the future. Building and plant itself will be fully contained, so we'll have full odor and sound mitigation components. So we shouldn't see any and hear any of that from this new plant. So some of the things that were considered is the new wastewater treatment plant sizing. Sizing was designed to be for a population of 9,015 based on 530 liters per capita per day volume of inflow of the plant. This growth estimate was based on the OCP at the time that was done just prior to design that estimated 0.6% population growth annually, and that's something that council approved at the time back when the design started. So what is our plan for population growth in the future? Should we go beyond 9,015 residents? We have already got a water conservation plan that has been developed for the city of Kimberley. We will be to initiate that. Will help with flow from use. So we're be something that allow us to expand the duration of the plant useful life. And this will also develop comprehensive infiltration reduction that will help minimize the amount of inflow that comes from pipes or from street, that type of thing. So those actions will maximize population capacity for the new wastewater treatment. So there's some imagery of the new wastewater treatment location at 700 3 Avenue. So that is just beside hole number 1 on Purcell Gulf, and just the west of the Marysville Falls, just a little south and a little west of Marysville Falls. To give you a bit of context there. That location moves the wastewater treatment plant location outside of the 200-year flood zone area. This is a drawing from the design of the plant. Looking at the drawing on the left-hand side, there's a small area that's labs and offices, etc. All of the row of boxes across the top of the screen is the FCR. It's the greenhouse component of the water treatment plant, and all of the rest of the buildings to the south of that are all wastewater treatment plant componentry in incineration and biosolids handling and all that type of stuff. Treating the effluent to ensure that it can be released back to the river, etc. This is a slide that just shows a couple of images on the boards of the room. Shows a little bit about how the FC works. It essentially utilizes membranes and plant roots as a place for microbiology to habitate while it's doing its job taking care of the wastewater. So why is this wastewater treatment method chosen? It has a relatively compact footprint that's on the location that we have available. It's a relatively environmentally friendly process with the greenhouse component to it. Has a good visual appearance for the local people that are living nearby that may be impacted by that piece, and has the ability to provide reusable effluent to the facility immediately and actually for future other uses. There's an image there at the bottom that shows a view of what greenhouse facing, that's the north side of the building, that would towards new or possible future residential area there. So it's south in this image. Why not simply renovate the existing plant? Had a study done, considered that option. They made recommendations that would, in today's dollars, be significantly, not a significant difference compared to building a new plant itself. There are a lot of construction consideration to try and build a plant around that's already operating. And it would not bring us outside of the flood zone that we're looking to get away from. Being in the flood zone only poses risks, environmental risks, downstream ecosystems and water use. I'm going to hand over the financial part of it to Jim. He can explain that component of it. And Jim, want to come up or not? I guess yeah.
Thanks. So there's just a couple of slides here on the financial aspect of this. Grab a seat. So fairly high level now we're looking at here. At the end of the presentation, if there's any questions together with the technical stuff, if there's more questions on the financial, I'll do my best to answer them if you get a little more in depth. So the total project cost is over $95 million, $95.2 million. That estimate's comprised of $87 million to construction construct the actual plant, and just over $8 million for some offsite works, including outflow diffuser in St. Mary's River, some underground sewer, I believe, and water and decommissioning and demolition of the existing plant. So the $87 million estimated construction of the plant was completed in January 12th, 2022. So it's a fairly recent estimate, the recent that we have. We've applied for a grant for 73.33% cost, which is just about $7 million. The question on the referendum is with regards to borrowing. So we're anticipating borrowing 23.2 million. And then from reserves and development reserve, which is funded primarily through the sale of some non-core assets by the city over the last couple of years. We're taking just over about $2.2 million of that reserve to fund the rest of the project. So, but the question on the ballot, the referendum is going to be approval to borrow $35 million. We're not planning on that $5 million being the long borrowing. We are only anticipating borrowing the $23.2 million. But with the grant program that we've applied for, they don't get funding in advance. We're going to have sufficient cash flow on hand to those ongoing capital expenditures. And then on a quarterly basis, we'll submit a progress report to the province, and they'll reimburse us for that. So there's a bit of a time there. So what the $35 million will allow us to undertake short-term borrowing till we get the grant funds. So we do anticipate anything over 3.2 this borrowing will be repaid, and we'll just be with that $23.2 million at the end of the day. So what will it cost me? That's the big question. Council has provided direction that the servicing costs associated with the construction of the new plant be funded through a parcel tax. So the options are parcel tax, which those of you that own property in town, you'll see the aquatic center parcel tax. Your tax notices that's a parcel tax. The same amount is charged to every parcel of property in town, regardless of its classification, whether it be residential or commercial, or its size. The alternative to that would be through variable rate tax collection. So just increase the tax rate, and the more a property is worth, the more it would pay, and it creates some real inequities. If you had a look at the staff report that went to council in January of this year, it kind of details all that stuff. So based on numbers on the previous slide, the parcel tax works $277 a year, and it's based on 4,500 parcels to come up with that number. Parcel tax is again levied per parcel per unit, so every piece of property in town would be the same amount. And kicker with this thing, just given the timing. So this estimate was arrived at in January of this year. The $277 is based on an estimate, the interest rate. The money's probably going to be borrowed until 2024 or 2025. So $277, I can guarantee that's not going to be the final number. It'll be based on how much we ultimately end up borrowing, what the interest rate is at the time, and the number of parcels that exist that the tax is imposed. So all of those factors are going to change as we proceed through the process. The number will be different from that. The calculation will be the same. I don't know who wants to pick up. Chris, you jump back in.
Thank you.
Yeah.
Okay. So some of the other factors that we mentioned at the beginning, construction timing schedule, once funding and tendering factors, all those things in place, the physical construction of the facility itself is anticipated to take 3 years. That depends on the contractor and supply and all that sort of things, but what we're anticipating at this point. What will happen to the existing pollution control center? The existing PC will be decommissioned once the new facility is fully up and running. Transition may take 6 months to complete. Final determination of the use of the land is still to be decided and will likely be up to the council of the day, but most likely be naturalized to some extent for future use in some way. Will access to Marysville Falls, St. Mary's River be impacted? Certainly access will be impacted during construction, not necessarily to the falls itself, but beyond the falls. And access to the river, St. Mary's River through that route would be closed until the plant was constructed. It's something that's designed into the plant that we're going to be welcome the public to the site to see it. There will be some interpretive stuff on there and some information about the facility, etc. That allow people to come see things. Be a bit of a draw to the facility itself if in the area recreating Marysville Falls or accessing it, etc. And last slide, the elector assent vote referendum question. So that's a question that you will all see at vote time. And the information below regarding advanced voting, etc. Missed an important piece at the beginning of the presentation. My apologies. We do have the design team for Wastewater Treatment Plant dialed in tonight. They'll be listening in and available for the technical questions like that we might not be able to answer for you. So Jan and Matt are on the from Urban Systems to answer any of those questions. So to them for being here. I think that's it. Okay. I will.
Just put your hand up and bring the mic to you. I got the obvious question. What happens if it gets voted down? What do we do? Do we let this one run into the ground, or is there another option? There's a lot of other options. I think we call it options B through Z. The plant's running okay right now. We've got operators there. They're, it's probably running as good as in a few years. Obviously, the grant application we put in would not fare very well. We have to notify the province. The electors said, no, you can't borrow the money. So we would go back to the drawing board and probably do something called a liquid waste management plan, which is basically starting the design and the process from scratch. It's been 6-7 years so far to get to where we are tonight.
And how much money to do that whole process?
Probably close to $1 million. Yeah, and who knows, 6 or 7 years what it's going to cost to build a plant. So, but yeah, we would continue to run the existing plant into the ground and do the best we can with it. It's kind of like owning a vintage car. You do your best to keep it on the road and keep up with the maintenance, but eventually it's time to put it away. Yeah, good question. Thank you.
Back.
Are we? Oh, Grace, go.
I just have a question about the parcel tax. Will it be in addition to the existing parcel tax, which is for the pool, or will the pool parcel tax phase out in time for the parcel tax for the wastewater treatment plant to start showing up on our tax bills?
Well, part one is it's a separate parcel tax. That's how they work. They're identified for which purpose they're used for. but I'll pass over to Jim for when the timing of the aquatic parcel tax ending and the wastewater treatment plant starting.
Yeah, good question, Melanie. Thanks for that. So as Scott indicated, it is an additional parcel tax, has nothing to do with the pool parcel tax, so it will be an addition. But the pool parcel tax itself, it pays for the operating deficit for that facility, for the aquatic center, and it also pays for the existing debt payments associated with that facility. The final debt payment on the pool will be made in 2025. So in 2026, council will have the opportunity to reduce that parcel tax by the portion that was being used to pay for the debt, which is, it's right around $45. So at the time this debt would be coming on, this parcel tax would be coming online, $50 of the parcel tax, between 40 and 50. Can't be too specific at this point, but that would be dropping off, which would be essentially be an offset to the new parcel tax that's coming on.
I think in the proposal, you were saying the population expected to grow at 0.6. On the current design, would it be a big issue to add capacity should the population increase beyond the 9,000?
At this point, the plant is designed for that population. It's because of Kimberly's sort of how our population works here. We have a population that kind of decreases during the seasons for seasons, golf season, all that sort of stuff. So the plant is built to handle those kinds of increases and decreases. Certainly, just like the existing plant, over time, it's anticipated that there would be opportunity to do things to that plant that would make them more.
So it has the potential to be increased.
Yeah, we believe so. And the primary way to do that is through the inflow and infiltration program that we're going to be putting forward, along with this wastewater treatment plant that will help reduce the amount of actual sewage that we're treating.
Okay.
Yes.
So just for the laypersons out there, inflow and infiltration is water that doesn't come through from your house, basically, into the wastewater system. So we get a lot of stormwater that leaks in through the manholes. So we would be looking for ways to keep that stormwater out of the wastewater treatment plant. Another option is to ask the residents of Kimberley to use less than 530 liters per capita. We don't do a lot of water conservation right now, but it's something that other communities are doing, and there's a lot of potential for us to reduce that per capita usage of water and the amount going into the wastewater treatment plant.
Captain, it's based on actual findings, or is it leakage in all the pipes?
Well, no, it's water coming into the wastewater treatment plant.
Okay.
Yeah, not, yeah, yeah.
I'm just wondering about like interest rates. Are we like locked in? Is it 0% on the money we're borrowing?
Yeah, so the interest rate that was used in that $277 calculation was, that was put in there in January when that report went to council. At that point in time, we used an interest rate of 3%, which is what the municipal finance authority, who we borrow the funds through, indicated would be a reasonable estimate. As everybody knows, interest rates have been going up. There's some talk that they may go down, but yeah, for every 1% increase in interest rates, so if they went to redo that calculation, if you go from 3 to 4%, at 3%, the annual debt payments on that $23.25 million are about $1.2 million. For every 1% the interest rate goes up, the annual debt payment goes up by about $230,000. So that was the disclaimer on the last slide that I had there. We really until the time comes when we borrow, we know what we know what the interest rate is and what the number of parcels are. We're not going to know what that final number is going to be.
Over there.
So you say that this facility is state of the art. What's its track record? How long has it been in operation in other countries? And what's its life expectancy?
Good question, Steve. I'm actually going to defer to Urban Systems on that one. It is used a lot in Europe, but I don't know how long the technology has been there. So maybe John or Matt could jump in here. Hearing me?
Hi. Yeah.
Yeah. Can you
Yeah, hi,
can
Chris.
you
Can
turn
you-
up a little
can you
bit
hear me?
or speak a little louder, Matt? It's hard to hear you.
Okay, I'll try to speak louder. Is
Much
that
better.
any better? Okay. So the technologies in use, we just checked today. So they've got about 80. I think it was about 60 to 80 systems in operation around the world, and about another 30 or 40 under construction. It's primarily been used in Europe and Asia so far. The FCR is the second iteration of it. So there's a system by Organica in operation in Seychelles that's been there since 2014, and that's a slightly different system. It's a fed batch reactor. It's based on a slightly different process, but yeah, they have several of these in operation around the world.
How long have they been up and running? Matt, do you have that information?
I don't have that right here, but the one they started in Hungary. I'm going to say it's got to be around 20 years ago, and they've got an R&D facility that's been running there for about 20 years.
Thank you.
My first question is, are there comparable communities of the same climate, say running down to -25 around here? This greenhouse model, which sounds very interesting, do we have anything in Canada that's being done the same as what's being proposed here?
So I'll give you the high level answer, and maybe Matt or Jan might be able to add to that, but there isn't one currently operating at our elevation or with our snow loads. The urban systems work very closely with Organica to basically design this to fit our climate, our needs, and our influent and temperatures and all those things. So there's a lot of criteria that goes into the overall design of sizing and componentry and all that takes into consideration all those things. Is that a fair estimate, Matt?
Yeah, that's correct, Chris. There's facilities in Europe that are in places that that have winter, but none of them get quite as cold as Kimberley can. They're also generally not quite as sunny as Kimberley can be, so that helps the greenhouse. And the biggest thing I think that was special during the design of the Kimberley facility was the temperature of the sewage coming in, which was pretty low even for a Canadian installation. And so that affected the design, but that is accounted for in the design of the facility and the bioreactors.
Thank you.
I have one more question. Was the discussion about water meters, did it ever come into this process to reduce the consumption of water that's going to get used and having to be treated?
Yes, it is. We had the water conservation plan done by Urban Systems here, was reported to council several months ago. And in that report, there is consideration of water meters for residential and industrial use. But it's something that, is something that would be phased in over time and would have to be approved by council and all those kind of things. Yeah.
Anyone else?
I was sort of interested in the history of our existing plant. I have some knowledge about over the years that plant was run by different engineers and different staff, and it has been run on different capacities. 55% I heard was used quite often in the earlier days, not running at 100%. And I'm wondering what happened to the plant. Did it get run at a higher number when they believed that number was an efficient number to maintain the plant? Do you know what it runs at in these later years?
I do know the plant is running in compliance currently. We have very, very few events of non-compliance at the plant. As Kimberley has been growing incrementally over time, certainly the inflow to the plant has increased. We have a better understanding of what's coming into the plant now because we're monitoring flows in and out, those kinds of things. So we have a much better information base, database than we had previously. Certainly the operation of the plant has not really changed a lot over time. It's run essentially the same way it has for many, many years with a few minor modifications over time, but nothing really significant. So it's essentially operating today the way it has for a long period of time.
Hi, just wondering if it's the first one in North America, is permitting going to be a challenge, or would our funding application be tougher to get through the process because of we're the first ones? Like,
Hi, Cora. I think the first of its kind in North America is a great way to get funding from the province for design. The reality is it's a slight improvement, some slight changes over the plant that was already built in Seashelt, which attracted grant funding. So sometimes you throw these buzzwords out to attract grant funding and make the project a little more exciting, but it's only slightly more exciting than what's been happening in Seashelt. So we don't expect a lot of problems with permitting. We're having it looked at right now by the province, and the province was pretty excited about the design. The idea that we came up with back in 2016, they funded it to the tune of 2.2 million for the design. So I would say the province is on board with what we're planning to do here.
I have two questions. One is, how are you planning to utilize the reclaimed water? And secondly, has there been any consideration in developing some separate way of dealing with gray water from residences and businesses in town to reduce the amount of water going to the plant?
Yep. So currently at this point, the water reuse will be all internal. So it'll be for operational components inside the plant. It'll be for cleaning, all that sort of stuff. So it'll be all inside the plant at this point. The plant has the ability to provide the quality of effluent that's needed for reuse elsewhere. So it could be used for irrigation or something like that down the road in the future. But that's a whole other project of its own. Sorry, can you repeat that? The last one part was?
I wonder if there's been any consideration of developing systems in residential and commercial places to divert rainwater away from the sewage water.
Yeah, absolutely. Part of the water conservation plan also talks about inflow, and it's a requirement for us for our current permitting at the wastewater treatment plant and future permitting that we are at reducing inflow and infiltration. And infiltration is that, storm water, roof water, whatever that might be that's coming from residents within the community. So yeah, that definitely be looked at and worked on.
Thinking more about things like access to toilets.
Right. All of that water still has to go through the same treatment process that requires a wastewater treatment plant.
And there's been no thought of diverting that.
It would require another separate wastewater treatment. So it still has to be treated. Yeah.
Thanks.
It's currently not allowed in the BC building code. Really in BC, they haven't warmed up to the idea of using gray water.
Sorry, using gray water for other purposes, but we hope that'll come one day.
I'd like to circle back on, Scott, your reference to being able to increase the population of Kimberley with this new plant by diverting snow melt and groundwater and that sort of thing. What's the estimate or range of estimate for what that will get you in terms of being able to service a population?
I'm going to defer to my man Chris here on that calculation because he's the one who told me we could divert from it. But have we run the numbers?
At this time, we haven't done a calculation based on if we reduce 100 liters per capita. What does that buy you in population? We haven't run those numbers. No.
This is a great project, I think, and it's on the cutting edge and technology and all that. If I had one concern, it's the capacity of the facility. And the assumption for growth rate, I think, was less than 1% based on a previous slide. I think our growth rate is more like 2% over the last 3 or 4 years. And, it seems to be headed in one direction. So if I had a concern, it's that in 5 years' time, the plant's up and running and we're bumping up from a population standpoint against that capacity for the facility. So I'll ask that's my concern. I'll ask a second question. How scalable is the design and the facility footprint? Could we add another greenhouse train, if you will, to add additional capacity?
Yeah, good question. It's my understanding that there is things that could be done internally in the plant that could potentially grow capacity in the future. But that's outside of my expertise. So I'll refer to Jan and Matt on that question. Good evening, Jan.
Hello. Hi.
Yes, we can.
Hopefully you can hear me okay. All right. So I'm gonna answer this question in one part and then maybe pass to Matt on the second part. So the first question, or there was a question around sort of estimating the available capacity in the future. So there was a number on the slideshow, 530 liters per capita per day. Just to give you a sense of scale, in other communities, that number can start with a 3. So it can be sort of in the range of 300 to 350 liters per capita per day. So as kind of a coarse instrument, you could just take that percentage off the 530 liters per second and kind of plug it back into the lifespan of the plant. And I think the biggest opportunity, which you've already referred to, well, 2 opportunities. One would be just straight up water conservation, widespread kind of city widespread water conservation, and then addressing the, as you mentioned, Chris and Scott, the water that's getting into your sewer pipes that's not supposed to be there, and that's the inflow and infiltration. So it's kind of over and above what a shower or a sink or a toilet contributes to the pipes. It's that extraneous water that's coming from somewhere else. So those are the 2 biggest opportunities in creating capacity in the future plant. And then Matt, maybe I'll pass the ball to you to talk about potential to, within the footprint of the current design, how to increase capacity through either the process or the equipment.
Hi, thanks, Jan. So yeah, basically on the site that's available there's not really a lot of opportunity or any opportunity to make a larger facility. There is some opportunity. So particularly if when combined with some of the offsite measures, things that can reduce the sewage volume and thereby kind of increase its strength. There are also potentially some pH things there that could be managed that kind of create a design here. In the combination of those things, there are some things inside the facility that can be done. And so it comes back to there was a slide that Chris showed earlier, and it talked about the density of biomass in the system. And basically in this type of system, and it doesn't matter if it's an activated sludge system or an MBR or just general aerated secondary sewage treatment, the fundamental capacity of it is governed by the amount of biomass that's available to consume the food, and the food being the sewage that goes in there. And so there is some capacity within this facility to increase that biomass. And so there are some, the biomass is held as a fixed film in this system. Some of it's with the plant roots, but actually most of it is on a synthetic media that's on these long kind of stringy cassettes that hang in the water. And the number of those cassettes can be increased. And so in concert with that, you would increase the aeration power. But those are things that could be done. And certainly, depending on the time frame of the construction of this facility, it could easily, and it's probably likely to be, it could be easily be, up to 5 years after the design was complete. It would be prudent to just revisit, as you say, what's actually happened in terms of population change and see if any changes need to be made before construction.
Thanks, Matt. Steve's got one over here.
Well, after what you just said, I'm just a little bit concerned about we should have a backup plan in case we have developers that want to come in and, build some buildings and we increase our population to 12,000, in 10 years. Shouldn't we have like a contingency plan and in fact, in case we don't have the capacity to deal with this problem? I'm just seeing a potential problem down the road.
If I may, reducing our water consumption under 400 liters per capita would actually equal that out. That would net zero that growth up to almost 12,000.
You mentioned the additional water that is not necessarily gray water or sewage water, and controlling it and diverting it. What would that involve? Because are we talking about roof runoff? We're talking about storm runoff. We're talking about driveways that get hosed down. That water, what kind of system would have to be put in place to facilitate that to manifest that?
Yeah, good question. It's a lot of those things. It's certainly water that gets put into the sewer system from a home, from either the roof or from a sump pump or something like that. Those are really quick ones to fix. Sometimes they involve the requirement to install storm pipe infrastructure under the ground for that water to go somewhere else. But there's a lot of opportunity for us to reduce the amount of rainwater that gets into manholes that's flowing on the street where it shouldn't be necessarily, and diverting it, keeping it in the ditches, making sure it gets to the storm infrastructure that is there, all those kinds of things. Heavy rainstorms and snow melt are both contributors to that. Snow melt's the worst because it's very cold water.
Where the plant's meant to be, is that going to be a solar aspect to that at all? Because that area is pretty treed. Is there going to be big clearance of trees? Is there going to be solar availability to this plant?
Yeah, yes, there will be a lot of tree removal done at site, particularly because it's a greenhouse, so we want the sun. And because of the small footprint, most of the trees at that site will have to be removed. There was some solar things considered during the design, but at this point, it's not in the design plan.
I'm just wondering about the stormwater diversion that you mentioned, and I'm wondering if permeable surfaces, swales, kind of thing would fit in to return water to groundwater rather than direct.
Yep, absolutely. We look at those things in areas where we can. Sometimes we can, sometimes we can't, just depend on the topography and the nature of the grounds and soils in the area and all sorts of things. So those are something that we always look at when we're designing new roads and new infrastructure. Yep.
I have one last question. There was one report I read and it had contaminants, like maybe a paint solvent or something that was found in the water. Would anything be killing the plants that would be in the greenhouse?
Anything like that impacts any plant, whether it's Organica or any other. Currently, if we ever experience something like that in the existing plant, it's extremely impactful and it's very difficult to manage, very difficult to recover from. So yeah, that can always impact the operation no matter what type.
Can I add to that, Chris?
Absolutely.
Sometimes, Cora, the plants that you choose to be the root media can sometimes absorb some of those chemicals and pollutants out of the water. Things like cattails are used to absorb those chemicals, and then they're cut down, harvested, and disposed of as toxic waste. So sometimes, depending on what you plant, which will be unique to Kimberley because of its altitude and temperatures, we can look at different plants that might absorb some of those chemicals.
Okay. Go ahead, Jan.
Just pressing buttons over here. So I just wanted to add something to that. So that kind of greenhouse portion of the process includes, like we say plants kind of interchangeably. We're talking about like green plants here, and the roots hang down into kind of like a water tank with the effluent flowing through. And it's a combination of living plants with their roots, as well as the kind of cassette strings that Matt was describing. So it's like a organic synthetic combination. And the real kind of benefit of the plant roots is creating that habitat for the biology to grow. And if a plant dies, like if a green plant dies, then the root mass still provides that habitat. And then the operators can identify that a plant has died and change it out while kind of the rest of the system takes up the slack. So not ideal that a plant would die in the process, but it is also not kind of a catastrophic thing for the entire food chain.
Just wondering about the rehabilitation of the existing plant and like cost estimate that you have right now. What would that leave the kind of the riverside area? What kind of condition would it leave it in? What?
Me to tackle that one.
Okay, you want?
I think it's going to leave a beautiful blank slate of riverfront for a future council to decide what to do with it. So that's not a very technical answer, but we're pretty excited to see the potential of that site. It's kind of been off limits since 1967 at least, and so we really can imagine things like river access in and out with rafts and kayaks and dog walking parks, things like that. Not to fetter future council's decision on what to do with that land, but I think there's heaps of potential for some pretty neat stuff down there.
You want to do the technical part?
I just have a question. I think you guys have done a great job with the planning and everything, but the fact that it's on a floodplain and that it's in poor condition, We've seen a lot of flooding now in Lower Mainland in the last 5 or 6 years. Yellowstone this year. There's a real good potential of it happening. And it just going to a referendum, nobody wants their taxes to be raised. I'm just scared that if it does get voted down and it does flood, that Kimberley's in trouble. And it's going to have to happen. Do you have any comments on that?
Yeah, sure, I can comment on that. Certainly, there's always that potential. We don't know what Mother Nature is going to throw at us. Should that happen, obviously it would be a pretty serious environmental situation that we'd have to deal with. And it would likely trigger orders that would require the city of Kimberley to construct a new plant. We wouldn't get the option of saying at that point.
Mm-hmm. That's my question, is why it would go to a referendum and why they just wouldn't push it through.
Yeah, just to jump in on that, Chris is quite right. I mean, the way it stands now, we're obligated through legislation to seek elector assent. So if this gets voted down, or in all likelihood, Ministry of Environment will eventually put an order, slap some orders on us. And in that case, if there is an outstanding order, then that requirement for elector assent, elector approval for the borrowing is set aside, and we just proceed.
Okay.
Yeah.
And I was just wondering if there's any chance, or I'm sure you guys have looked into it, but federal grants or federal funding at all, not just provincial.
Yeah, this is it's a combination. It's federal and provincial funding. Yeah. Yep.
I'm just not understanding what happens to the effluent. You say it's recycled or reused, but is there no discharge of potable water to the river? Or, I mean, there's going to be a volume of water here. I just don't understand at the end of the stream where it goes.
Yeah, so we'll be using water inside the facility that we're producing because we have a high enough quality to do that. That just means that we're drawing that water from the distribution system that's supplying drinking water to. So we're doing our part as far as water conservation goes inside the facility. We will still be sending the finished product effluent into the St. Mary's River, basically in very similar location to where it is today. Similar fashion. Yeah.
Can you talk a little bit about biosolids you're currently in for disposal, whether that's going to continue, how viable is your site
on the facility?
Where are they now? Is it going to keep there? Costs is the same? Is it going to push back the road? Okay, that's bio.
Yeah, so the existing PCC creates a fair bit of biosolids. It's not as efficient as a new facility. And currently what we're doing is we're storing those in geotubes, which is essentially like a giant sock filter that allows moisture to escape from that. And then we're taking biosolids and hauling them to the regional landfill, regional district, and they're using them for compost and such at site. There's a cost to that. There's a cost to deliver to the site and a cost for us to truck it there. Those costs are a little bit higher in the last year or two because we had a backlog of biosolids to deal with. So essentially we're kind of caught up now. We're going to do our best to stay ahead of them on that and keep our costs kind of a regular cost rather than a hit all at once for a number of years. So that's what we're working on there currently. The new site will see biosolids dewatered on site and put directly into bins that will be hauled off the regional landfill and put into the compost facility there on a regular basis. Hope that answers your question.
Do you know what they're doing with it when they're done with it?
My understanding is the regional district is really using it in their compost facility and have some other uses for it. And Nick might be able to that actually.
Maybe there. So currently it's going into.
It'll be close there.
Sorry. Currently it is going into the landfill. the regional district is in the process of building a composting facility, which should be in operation next year. And these biosolids will be fed into that composting facility going forward.
Was there any discussion on this project with energy recovery from the biosolids, anaerobic digestion? Did you talk about carbon footprint when you were evaluating the costs?
I believe that was discussed early on, but we just didn't have the foot to make that happen at this site. Not to say that there's some research done into that in the future.
Was the backlog of biosolids kind of creating, extra odor for residents in Marysville? And with the removal of all that, is that kind of what's keeping it down a bit and why this year was better? And going forward, what strategies are in place to kind of ensure that there's less odor in the meantime until this project gets approved?
Yeah, absolutely. We had a backlog of biosolids creating some struggles for the plant operation recently with what has done at site over the last year or so. It's plant operating better. There's less biosolids. There's less things at site we're having to deal with that creators. We're anticipating that we're going to continue on with that process. That site is no longer being used. So we're anticipating that what you've experienced this year will be more the norm than not in the future if we keep the plant operating the way it is.
Chris, can you tell them the centrifuge in the new plant? That speeds up the process.
For sure. So the new plant has a centrifuge into the facility itself, so it's contained inside. So the biosolids don't leave the facility until through a centrifuge, which essentially spins all the water out of the biosolids. The water then gets put into the process and helps things. The biosolids are then a much drier, lighter product, less expensive to remove, and are fully contained within the odor control system of the building. So, yeah.
I have a question for Jim. Evening, Jim. The estimate's $95 million. Who's on the hook if the project comes in above that? Say you have a cost overrun of 10%. Is it the city or is it government funding or a combination of both?
Unfortunately, it would be the city. We wouldn't be able to go back to the province or to the government at that time. Senior levels of government and ask for the grant funding increase. So if there were a cost overrun for whatever reason, I think what we'd probably end up doing is we'd look to our reserves or increasing the amount that we borrow. We are planning on borrowing the 23.25, but we do have the ability with the bylaw that we put forward to borrow up to $35 million. We certainly don't want to borrow any more than we have to, but it would, in all likelihood, it would probably be a combination of those two: additional money from reserves and some additional borrowing as well.
Is it a Class A estimate?
It's Class B. Yeah, so Class B, and along with the ICIP grants application, what they require for a Class B estimate is a contingency of 15%. So the estimate that we received from the engineer actually had a 5% contingency built into that Class B estimate. And we bumped that up to 15%, just because it's not a Class A.
Jan, you had your hand raised, but I saw that you were nodding when Jim said the contingency was 15%. We're all good?
Can we do that, Maurice, or Pam? Too many. Did we go to? Nope. One more.
One more.
That one.
Okay. Just a minute. We'll get it here.
Sorry. So, there, there's some all along.
Yep.
That's the inside, and there's flat roof outside.
It depends on what angle you're looking at, right? The
Yeah.
one's a side view.
Yeah.
And one is sort of head on.
Okay, so there's
Yeah.
a lot of peaks and valleys.
There in the actual design in the drawings. There's a number of peaks and valleys in the greenhouse.
Yeah, and that they for sure taken in our snow loads. because
Yeah, absolutely.
That's not an issue.
Many long conversations about. Sorry, we've had many long conversations with the design team, engineers that are doing the greenhouse structures. It's been reviewed several times, and they've assured us that that's the best design for strength and for the actual effects of the greenhouse itself.
So, because you think it would just block so much light with all those valleys that it wouldn't be very functional at all.
Yeah.
Yeah.
Originally, we thought the same, and we've gone to the Urban Systems has gone to the greenhouse designers and had those conversations with them.
Okay, no more. Oh.
Kind of going back to capacity considerations, like it seems like a really small footprint. And I guess in my mind, I guess it's kind of the low point. That's probably where it has to be. But was there any other sites considered or any other possibilities or?
Certainly looked at all available land and places we have where we could facility. Really limited to the fact that everything kind of verges at that location. So it didn't leave us a lot of opportunities being surrounded by tech and courses. Really limited our options there. Yeah, we did look at things, but that was ultimately the site we found that we could fit it in.
Last call.
Well, I don't have a question, but I really am amazed at the wonderful work you guys have done. I know it's gone on like for 6 years now and working with Urban Systems, and every time we talked, there was something else that we brought up that we weren't happy with. And now you guys have come up with this amazing presentation, and I just can't believe that we're there. I encourage everybody to put your hand up and say, let's move on with this. Because if we wake up one morning and we can't flush our toilet, it'll be 2 years before we can.
Great note. It is we just want to remind people it is a gravity system, so your toilets will still flush. Just you just wouldn't want to be downstream from us. I think what we're going to do, a lot of people don't like these forums and don't like public speaking, and might be a bit shy to ask questions. So what we're going to do is we're going to let people mill around, ask questions of staff. Maybe we'll stand next to some of the posters. You can have a look at some of the information we have up. Feel free to ask us here tonight, up to and including up to the referendum. If you have questions, please, well, don't email Chris because his emails will be forwarded to Nick, and he's got his hands full. But we're more than happy to answer questions tonight and going forward. So thank you, everyone, for attending. We really appreciate it. So good to see people in council chambers again. I can't tell you. It's been a bit of an echo chamber for 2.5 years. We really appreciate it. And thanks again to Chris Mummery, not just for all his work over the last 6-7 years in getting us to this point, but the last 35 years working for the city. So maybe we can have one last round of applause for Chris. All right, thanks everyone.
I'd just like to thank everybody for their excellent questions.
Yeah.
It really helps us get the information out there that you guys need to hear. So thanks very much for participating and asking lots of good questions. Much appreciated.
Yeah.
Thanks, John.
Yep. Thanks, John. Thanks, Matt.
Thanks, John. Thanks, John.